everyone, in this lesson we're going to be talking about inverse trig with a calculator. So we're going to be either using a calculator or Desmos. I will show you both just to make sure you're comfortable with whatever implement you are using. Um, so that's our goal. These are just a reminder of what our restricted domains and ranges are for our inverse trig functions. Of course, we didn't focus too terribly much on inverse cotangent, inverse secant, or inverse cosecant last class, and that's okay. But that's just a picture to remind you. So goal, we're going to use our calculator. We're going to evaluate those inverse trig functions in their restricted domains. All right, so let's just recap here some basic trig functions and how to put them into a calculator or into Desmos. We are going to be in degrees only when we're using a calculator. So when we're not using a calculator, we are using radians, okay? Because we can do those. We should have those memorized in our heads. All right. But when we're using our calculator, we are going to be using degree mode. So whatever you're using, whether it be Desmos, which I'm going to pull over right now, make sure that you click the little wrench at the top, because every time you go back and forth between it, unless you have the app, I believe, you're going to have to change your settings. So we're going to click degrees and make sure that's good to go. If you're using a TI 83 or 84 or potentially higher than that, what you want to do is you want to click mode and you want to make sure that degree is highlighted, just like mine is right now. Okay, so with that, let's take a look at our notes here. So our first part, we're just looking at our primary functions, and we're literally just plugging these into our calculator. Okay. The instructions aren't on my screen, but they are on the notes. On the notes, it says we're going to round our trig ratios to 3 decimal places and our angles to the nearest tenth. All right, so 3 decimal places is our goal. So we're just literally going to type these in. So sine of 35 degrees, on the calculator, it's very simple. You click the sine button, you put in 35, you hit enter. Okay, and you get 0.574 when we round to that nearest third decimal place. Okay, you can keep plugging these in. Cosine of 14, again, the button's right there. Easily we can do that. So that'll be 0.970. And the tangent button is right there. So 170 is what we're plugging in. Okay, and we get negative 0.176. All right, so there's a few more examples that you can try on your own on the note sheet. Let me just take a moment and fill in the ones that I've done for you, and then I will fill in the answers. So feel free to just be trying those on your own, and I will also show you how easy it is on Desmos to do those basic trig functions as well. So again, today is all just using our calculator and getting some answers. So here are the other 3 answers here. All right, for you. So let's move on real quick. Sorry, let me talk about Desmos. So with Desmos, 2 ways that you can get your trig functions to show up. You can literally type in, like if I wanted to find sine of negative 100, I literally type in SIN, and then I type the problem. You can also use the keyboard, click functions, and you can click any of your sine, cosine, tangent, cosecant, secant, cotangent, and their inverses. All right, so you don't even have to type it if you don't want to. It's just right there in functions in the trig. Okay. So let's look at our notes one more time here. So these are our reciprocal functions, right? Secant, cosecant, cotangent. We should know that secant is the reciprocal of cosine, right? So that means that secant of 35 is the same as 1 divided by secant of 30. Or sorry, not 1 divided by secant of 35, but 1 divided by cosine of 35. So 1 over cosine of 35. And that's how you're going to have to type it in if you're using a calculator. So I'll show you that really quick. So 1 divided by cosine of 35. There is my amount, 1.221. Okay. 1.221. If I wanted to find cosecant of 18 using my graphing calculator, I'm going to have to do 1 divided by sine of 18. And to do cotangent, you can do 1 divided by tangent of 70. Now, good news, Desmos, you don't have to do that, okay? You can literally type in, for instance, if we wanted cosecant of 18, there we go, 3.236. Okay, I don't have to do 1 divided by. I can, and I will still get the same thing, 1 divided by sine of 18. Notice it gives me the exact same answer. Okay, so it's up to you whether you want to use Desmos or your calculator. I'm just going to put the answers in. Feel free to try them on your own. Make sure you get the same answers. And if you're not getting the same answers, double check that you are in the correct mode, which should be degree mode. So here are the final answers for that second section of the notes. All right, so now let's move on to the last section of the notes. This gets a little bit more difficult, okay, but not too terribly much so. So our goal is to find our angles. We're finding the inverse now, not just straight, angle the way it is or problem the way it is. So we're finding our inverse. We're going to round to the nearest tenth when necessary because these are all going to be angles. So if my problem is sine of theta equals 0.3491, I want to find, my theta. Okay, so on the note sheet it says theta. On the screen here it says inverse angle. So in order to do that on the calculator, you're going to hit second and then whatever trig function you're working with. So inverse sine is right there. I'm going to type in 0.3491 and then I press enter. Okay, and I get 20.4 degrees. Okay, on Desmos, all right, remember I already showed you actually that you can use the buttons here if you so desire. You can also type it. You can do sine and then you go shift 6 and it gets you up to that top, so -1, and then you just put in again the number that you have. Okay, and we get the exact same thing. So however you do it is fine by me. Just make sure you're comfortable getting those numbers. So real quick, let's go ahead and find all of these angles. So my inverse angle for sine of theta, I already showed you. That's 20.4. All right, inverse cosine. So for the next one, you would get 99.8. I'm just going to do this column real quick. Tangent theta of equals -0.4951, you end up getting -26.3 degrees. Now, when you're doing the inverse cosecant, secant, and cotangent, again, I would recommend using Desmos so you don't have to worry about 1 over, the inverse of sine or 1 over the inverse of cosine. Totally up to you though. So for cosecant, for your next one, you're going to get 25.6 degrees, sorry, -25.6 degrees. For secant, you'll get 102.3 degrees. And for cotangent, you'll get 36.6 degrees. Now, let's talk about the remaining things here. So we've talked about reference angles before. Remember, reference angles are the acute angle to the nearest horizontal or x-axis. Okay, so when you look at this angle, 20.4, the reference angle is itself. It's 20.4. That's the acute angle to the closest x-axis. Whereas when you look at the angle 99.8, all right, that is not acute, it's over here. And so your closest x-axis is right here. So to find that distance, you just take 180 and you subtract that amount, okay, and that will get you 80.2 degrees. Remember, your reference angle is always positive. So like with your next two, you have -26.3, all right? So that, is in the fourth quadrant down here, but the closest x-axis is still right here. So just make the angle positive. So 26.3 degrees, 25.6 degrees, We have another obtuse angle, 102.3, so we know that would be in our second quadrant. So we're going to subtract that amount from 180 to get 77.7 degrees. And then finally, the last one, it already is its own reference angle. Okay, now let's talk about the next two columns, and we'll do those literally just kind of going row by row instead of going straight down the whole column. So it says quadrant angle, quadrant angle. What that means there, what we're looking for there, you need to tell me when this particular angle happens. Okay, so when is sine, and this is positive. Okay, when is sine positive? And you should be thinking, well, it's positive in quadrant 1 and in quadrant 2. Okay, now let's think about the angle. Okay, so your inverse angle that you got, 20.4, actually is in quadrant 1. So that is the angle for that particular quadrant. Now, in quadrant 2, if we want to figure out, what would this angle be if we were in quadrant 2? All right. Well, think about where quadrant 2 is, right? It's past this. Okay, all right, somewhere in there is in quadrant 2. So what we want to do is we want to say, okay, well, we know this whole line is 180, so let's go back 20.4 degrees, and that will be our equivalent angle in quadrant 2. So in quadrant 2, our angle is 159.6 degrees. Okay, it's a little bit weird, but we can manage. All right, for our next one, cosine, it's negative. So when is cosine negative? This is something that should be fairly easy, this part. So cosine is negative, definitely in quadrant 2 and in quadrant 3. Okay, now my angle, 99.8, is actually already in quadrant 2, right? Because it's more than 90 degrees. It's already in quadrant 2. Yay, I don't have to do any work for that. Now, we want to also figure out the angle that it would be in quadrant 3. And this is where our reference angle helps us. Okay, so we want to get ourselves into quadrant 3. Here's the line in between 2 and 3. We want to add our reference angle to 180. So 180 plus my reference angle will get me into quadrant 3. And so that's going to be 260.2. So our reference angle always helps us somehow. All right, for tangent to be negative, that's going to occur in the second and fourth quadrants. Now 26.3 is in the first quadrant. We need to get into the second quadrant. So again, this is where we're going to take that 180 and subtract the 26.3 so we can go upwards from that 180 into here, into quadrant 2. So 180 minus 26.3 gets me 153.7 degrees. Quadrant 4, now this is a little bit different. So, normally we just, subtract from 180, but remember quadrant 4, we've almost got a full circle. So we're going to actually subtract from 360. So 360 minus 26.3 is 333.7 degrees. All right, so for cosecant to be negative, remember cosecant's the reciprocal of sine, so just think about when is sine negative, and that's in the third and fourth quadrants. Okay, now 26.6 is not in the third quadrant, it's not in the fourth quadrant, so we're going to have to do some work. So if we're in the third quadrant, we want to add our reference angle to 180. 180 plus 25.6 gets me 205.6 degrees. In quadrant 4, remember that's 360 minus that reference angle, and that's going to be 334.4 degrees. Secant, when is it negative? Whenever cosine is negative. So when is cosine negative? In the second and third quadrants. Okay, so 102.3 is actually already in my second quadrant, so I don't have to do any work for that. Now to get into quadrant 3, we're going to do 180 plus our reference angle. So 180 plus our reference angle is 257.7 degrees. And then when is cotangent positive? That's going to happen in your first and your third quadrants. All right, so 36.6, again, already in my first quadrant. To get it into the third quadrant, that's when we do 180 plus 36.6 to get 216.6 degrees. So that is inverse trigonometry using your calculator.